Imagine a world where human intelligence and artificial intelligence merge seamlessly, creating a new era of possibilities. At the heart of this vision are brain-computer interfaces, BCIs, devices that connect the human brain with external computing systems, allowing unprecedented interaction. BCIs could revolutionize our interaction with technology, enabling control of digital devices and prosthetics with our thoughts, making the impossible possible. Picture controlling a computer cursor with your mind, effortlessly navigating the digital world, or downloading information directly into your brain, accelerating learning and knowledge acquisition. The potential benefits are vast, from restoring lost functions in paralyzed individuals to enhancing human cognition, pushing the boundaries of what we can achieve. As we approach this technological revolution, we must weigh both its promises and ethical challenges, ensuring a balanced and thoughtful integration into society. Neuralink, founded by Elon Musk, is at the forefront of BCI research. Their goal is to create a high-bandwidth, minimally invasive BCI that integrates the human brain with AI. By implanting thousands of microscopic electrodes, Neuralink aims to treat neurological disorders and enhance human capabilities. Neuralink has made significant progress, successfully implanting BCIs in animals and planning human trials soon. In fact, the first human test has been already completed, and the person in question, paralyzed with a spinal cord injury, can now interact with the world through only his mind, making use of a PC without using his arms, for example. Numerous other companies and research institutions are also exploring different approaches to BCIs. Beyond the Neuralink, various companies and institutions are developing BCIs using different methods, each with unique approaches and technologies. Non-invasive techniques like EEG and MEGI measure brain activity from outside the skull, providing valuable data without the need for surgery. Partially invasive devices like EKG arrays are placed on the brain's surface, offering a balance between signal quality and invasiveness. Each method has its pros and cons regarding invasiveness, signal quality, and applications, making it crucial to choose the right approach for specific needs. Ethical considerations include privacy, data security, and social inequality, which must be addressed to ensure fair and safe use of BCIs. Open dialogue among scientists, ethicists, policymakers, and the public is essential for responsible innovation, fostering trust and understanding. BCIs have the potential to transform society, but we must navigate these ethical challenges carefully to ensure they benefit everyone. Brain-computer interfaces, or BCIs, could revolutionize not just work but also education and human interaction in ways we are only beginning to imagine. In the workplace, they could significantly enhance productivity, streamline complex tasks, and enable new, innovative forms of collaboration that were previously unimaginable. Education could be personalized to each student's needs, and learning could be accelerated, making it more efficient and effective. However, these advancements come with potential drawbacks, such as job displacement, ethical dilemmas, and fairness concerns that need to be addressed. Critics warn of unintended consequences, including privacy issues and societal inequality, while proponents see it as the next step in human evolution and progress. As we stand on the brink of this new frontier, thoughtful dialogue, responsible innovation, and ethical considerations are crucial to ensuring a brighter, more inclusive future for all. If you found this video insightful, please like, share, and subscribe for more content on the future of technology and its impact on our lives.